everybody, and welcome to another episode of Sneak in Some Science with Miss Mercury. Today's show, we're going to be looking at the word density. We'll get to what that means in a second. What I want to do first is share with you a little bit of background information on two very important words. In order to talk about density, we need to talk about volume and mass. Volume is how much space something takes up. So, let's look at this water container. If I open up this water container and fill it up with some water, we would say that the water takes up this amount of space. That's the volume of water. Now, if I had a really large water bottle, that means that the volume could be greater. If I had a really tiny water bottle, the volume would be smaller. They have the same size, the same measurements, the same shape. They have the same volume. But I've done something a little different in this container. I've taken this container and I've filled it up with water. So this container is filled with air, and this container is filled with water. Let me ask you this question. Which container do you think is heavier? So if I put them on a scale, like a scale in a bathroom or in the kitchen, and I put this one down, and then I put this one down, which one do you think it would say would weigh more? Would it be the one with the air in it, or the one that's filled with water? I hope that you said it would be the one that's filled with water, because I have filled up this container with water, and this water has a lot of stuff inside of it. Now, I'm saying the word stuff, but what I really mean are molecules and materials and all these things that just sort of fill up that space. Mass is the amount of stuff that takes up a given space. Let's look at another example. Right here, I have two Ziploc bags full of some candy. They are the identical Ziploc bag, and one bag has all of these candies inside, and this bag has all these little candies inside. So, our bags have the same volume, or they take up the same amount of space. But what I've done differently is I've placed different amounts of stuff inside of the bags. Which bag is more dense? Is it this bag, or is it this bag? I hope that you said it was this bag. Now imagine these are little pieces of stuffs and molecules and things that make up the space inside. There are more things inside of this bag than there are inside of this bag. So there's more mass to this bag than this bag. We would also use the expression that this bag is more dense than this bag. Now we can add our final word of the day to all of this, which is the word density. Density is a word that we use to describe how much stuff is inside of a given space. Another word that we sometimes connect to density is buoyancy, or how something will float. Density will help you predict if something can float. All of these words are interconnected, and we can use them in a lot of fun experiments. Today's investigation is going to be fun because I've made it edible, which means you can eat it, of course with your parents' permission. I'm going to be using some candy Skittles, which come in a variety of different colors and flavors, as you can see in these bags here. You'll also need some small cups that we can put in some warm water and the Skittles to melt down the Skittles themselves. a tablespoon, a pipette or something to squeeze out the liquid, something to stir with, and some hot water. Not too hot, but warm enough to melt the Skittles in the cups. So what we'd like to look at today is density and how density works. The first thing that I'm gonna do is I'm gonna categorize by color the Skittles that I have in my bag. Now, how many do you need to use? I wouldn't use more than 15 per color, but I'd like to get on the sort of the end of at least 1 or 2 for some of the other colors. Let's see what we have. Okay, so it looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 blue Skittles. I have 1, 2, 3, 4, 5, 6, 7, 8. 8 yellow Skittles. 1, 2, 3, 4, 5, 6 orange Skittles, 4 pink, and 2 green. So I wanted to have a nice variety of the numbers of Skittles. All of these guys right here, well, this can just be my snacking tool as I'm doing my investigation. The next step is to pour just about 2 tablespoons of warm water over the Skittles to help them dissolve. You can see they're already starting to dissolve a little bit. I can see that the color is coming out of the Skittle and the Skittles themselves are getting a little white. Time for a snack. I'm already loving the colors of the cups. So now that we've allowed our candies to dissolve a little bit more or break down in the containers, now we're gonna do is try to see if we can see which one of these colors with the candies as we pour them slowly in a jar might be the most dense to the least dense. So we're gonna go over here and I'm gonna slowly pour it down the sides. I'm gonna add quite a bit, but I'm gonna use the pipette to help us get some of our liquid down. Okay, so now we have our blue layer. So remember, there were a lot of blue candies inside blue. We're gonna go next to our yellow, and I want you to think about what's going to happen as we very slowly take this solution, this mixture of yellow, and we pour it on top of the layer of blue Skittles. Let's see. Yep, those are 2 definitely distinct colored layers. Right, I'm gonna try to see what happens when I do the orange. If I remember correctly, we had more candies in the yellow than we did in the orange. So let's see if we can predict where this layer will go. I'm having a hard time showing the difference between the orange layer and the yellow layer. And let's try the red one. Ooh, look at that. That pink layer is definitely on the top. There were less candies in this container. So what do we notice is happening? The containers that had the most amount of Skittles in them, that dissolved the most amount of Skittles, seem to be hanging out at the bottom of the jar. The containers that had the least amount of Skittles in them, as pretty and pink as they are, seem to be hanging out at the top of the jar. Why is that? Doesn't everything have water in it? And we know that water is going to be just as dense as water. So what makes each one of these containers different? I hope you said that the amount of Skittles that's in the container that dissolved is what's really important. Each one of these Skittles contains not only food coloring, but also sugar. And so as we dissolve each one of these Skittles, it not only dissolves that color, it dissolves that sugar, and it changes the density or how much stuff is inside of this space. So now this cup of blue water, which is really Skittles, has tons of not only food coloring, but also sugar. And so even though we have the same amount of volume of each one of these, there's more stuff inside. There are only 2 green Skittles inside of the green mixture, which means that there's only 2 amounts of Skittles and sugar inside of the green mixture. If I had to predict where the green would go, if I were to take the pipette and put it in there, it'd probably be at the very top. Of course, it doesn't look like our rainbow jar is absolutely perfect, but I can definitely see the rainbow. This is my favorite part of the episode. It's called Phone a Science Enthusiast. And so I've got the perfect person on the line, and they're a super science enthusiast, and they do something super, super cool. And I'm wondering how many of you have done this before. Are you there? Hello? Hi, how are you? Good. And who is on the line today?
Sophia.
Sophia. Wonderful, Sophia. And how old are you, Sophia?
9 years old.
Excellent. And where do you live?
I live in Connecticut.
You live in Connecticut. I love it. And tell me, Sophia, you have this really fun science-y pastime. Tell me a little bit more about something that you like to create that's very science-y.
I love to create slime. I make it a lot.
And you make it a lot. And what are some of the ingredients of slime? I actually don't know. I think I've made it before, but I don't remember. What are some of the major things that go into making slime?
Well, you're definitely going to need a base, and usually a base is either glue or some sort of candy.
Okay. A base like glue or candy. Okay. And then how do you stir it together? Is that kind of how it works? You mix it all up?
Yep.
And then do you have to put it like in the refrigerator or in the oven or anything?
You have to add other ingredients before you start mixing.
Okay, so you have to add other ingredients before you start mixing. And then how long does it take before you can start playing with it?
About 2 minutes.
What do you do to make it so colorful?
Food coloring, you can use food coloring or paint.
You can use food coloring or paint. Okay, that sounds cool. And so I know that there's different ways to make it. Have you ever had a problem with making it and it didn't turn out so great? And what happened?
Yes, I have. I ran into a problem many times, and the problem is usually bubbles.
It's bubbles. Okay, so you have too many bubbles in your slime. And then what can you do to get rid of that problem? What are the solutions to fix all the bubbles?
Well, you have to let it sit a little so the bubbles can rise to the top and start popping. And then start mixing it up.
Okay, excellent. Okay, so there are some solutions. I guess you got to do a little bit of science to figure out why they are and are not working. What do you do with the slime after you make it?
I do not sell it, and I don't give it to my friends. I mostly just play with it.
And how do you play with slime? What do you do?
I can stretch it, make swirls, make shapes. You can make many different, stuff with your slime.
It sounds very relaxing, actually. Like just to kind of touch the slime and move the slime around. That sounds pretty cool. I like that. Well, I think it's awesome, and I think that it makes you a mega science enthusiast because you investigate and create some awesome looking slime, and then you go and sort of update and fix your slime recipes and enjoy it. And I think it's fabulous. So, Sophia, before I get you off the phone today, tell me, do you have any fun upcoming summer plans before school gets started?
Yes.
What are you going to do?
We're going to take a 2-week trip to Outer Banks.
Wow, that sounds fabulous. 2 weeks? What kinds of things are you going to do in the Outer Banks?
We're going to go to the beach, hopefully, and we're going with our friends.
Oh, that's wonderful. All right, well, I hope that while you're there and you continue on, make sure you try to do science every day because you are a super science enthusiast. And I'm so happy that we were able to chat with you about all of your slime awesomeness. And I hope you have a great trip and a wonderful time headed back to school as safely as possible. Thanks for being on the phone, Sophia.
Thank you.
What I'd like us to think about in the next week is really about being polite. Now, there are some very simple things that you can do to practice being polite. If you ask for something, always try to use the word please when asking for it. And then, of course, after you receive it, just simply say thank you. And don't forget, these words, please and thank you, don't just apply to the people that live around you, your families, and your friends, but also to strangers. So if someone does something nice for you, don't forget to say thank you. It's been another great episode. Gotta love edible episodes where we can snack on some of the things that we did. It was wonderful chatting with everybody about density and how much stuff there is in a space and looking at the density of melting our Skittles candy. Thank you so much, Sophia, for being a wonderful science enthusiast. We hope you continue your science journey with your slime. It sounds like so much fun. There's only one last thing to say, and that's thanks for joining another episode of Sneak in Some Science with Miss Mercury. I'll catch you later. Bye. Today's investigation is going to be a fun one because I've added in an edible. Today's investigation is going to be fun because I've made it editable. Oh, remember that episode where I ate all the Oreos all the time? We're doing the phase changes? Well, these Skittles, I mean, I'm enjoying them, but it's going to be another one of those situations where I'm not going to eat Skittles for months. Like months. Right side Skittles. I'm glad I got these instead of the other ones. It's a little bit softer in flavor. That one would be really harsh. So if we look at these 2 bags of Skittles, we can see that this bag, although it's the exact same as this Ziploc, Ziploc. Kind of feels good. They're falling out. I might as well just make sure that they don't completely fall on them. There we go. It's taking me so long to chew these things. Should I try it?